All right, so what we've got here is a little bit of set theory. It's not really all that hard. This is called set builder notation. It's just a way of writing something to show what uh, numbers are in a set. Uh, like, and the way you read this is, okay, let A equal the set of. That's what these curly braces mean. Anytime you see something in curly braces like that, that's a set. Okay, what this says, this is the set of all x such that, that's what this thing, it just means all x such that x is greater than negative 3. That just means all the numbers greater than negative 3 are in that set. Similarly, here we have b is the set of all x such that x is less than or equal to 0, which means it includes 0 and everything less than it. It doesn't really matter whether x is integers or usually x is used for real numbers. You use things like a and b for integers, but that you don't even need to know that. But it doesn't matter with the way you're going to be doing these problems at all. So, and then you have some other notation here. When you see something that's say a with this dill and then b, that's a intersect b. The intersect of a and b means where those two are the same. Everything, if something's in a and b, it's in this intersect. Think of that as an intersect. Okay, that means all x such that x is in a and b. Okay, so the way you would do this is, the way I would do this is, you think of, okay, if you want to take A intersect B, okay, let's do a number line. You got negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, and so if A is everything greater than or equal to negative 3, or greater than negative 3, that means it doesn't include 3, but it's everything on this side of it. All right, and then if B is everything less than or equal to 0, that means it includes 0. So you do the colored in dot and goes this way. And so everything not including negative 3, but including 0 and everything in between them is what this intersect is telling you. So this will equal, and so you're going to want to put you're going to want to put that back in this notation. So A, we say A intersect B equals the set, just like up here, of all x such that negative 3 is less than, strictly less than x, which itself is less than or equal to 0. And if you look, you can see here x is greater than negative 3 and x is less than or equal to 0, and that's all you have down here is x is greater than negative 3, but it's less than or equal to 0. So really, you don't even need the number line. That's just a way of visualizing it. You can take it directly from this. And then, for the other one, when you have something like this in between them, that means union. If I have A union B, that means everything that's in A or B. All of A and all of B put together. And so it will equal the set of all x such that, okay, x is greater than -3, or x is less than or equal to 0. The union, meaning both sets added together, is all x's that are in this one or this one, just the two up here combined. As opposed to this one, the intersect, once again, is that x has to be in both, which means it has to be this and this. All right? And that's really everything you need to know to do all of these. If you have any more questions, just let me know.